we're going to deal with testing the hypothesis. And it says testing hypothesis. My subset on this says the science and magic of hypothesis testing. Science because it goes back to a lot of mathematics. Magic because you have to know what you're doing. If you don't know what you're doing, what you end up getting is you end up getting some sort of magical result that gives you an impression that you may have something, where in actuality it is hocus pocus and it is nothing there. So when you do this, you have to have a clearly defined hypothesis, then you must have a properly chosen methodology in order to be able to analyze that hypothesis. And one of the things we see a lot of times is you use an approved statistical procedure in a wrong way, and when you do it, you really come up with nothing because you haven't proven anything. So, testing a hypothesis, what are we looking at? First question, what are the variables? We're going to go over variables. You have to know what are your independent variables, your dependent variables, and your controlled variables. You have to know where your variables are. You have to know what they've done. You have to know where things are. You have to separate them out by the proper variable, because you can't test something if you have the variables incorrectly placed. How will the variables be monitored? Will you be looking at different concentrations of the same variable? And if you are, then you're going to use one statistical procedure. Are you looking at different time periods? This requires a different statistical procedure. Are you looking at different locations? Again, is this a nested type design? What type of design is that? This needs to be looked at to make sure you use the right statistical procedure, because you just can't go out there and blanketly use something. Do you have different methods of application? Does this take into account differences that might be there? I saw one time they were applying things ground-based, they were applying things foliar-based, and they were looking at a ground-based observation, which means that the statistical procedure they looked at was totally irrelevant to what they were trying to do. And the question comes down to it. How good are you going to be able to go out there and do this? Just because it's out there doesn't mean that it's got any value to it. What are you going to be comparing? And how are you going to compare them? This becomes very important in there. And it says, what is the control treatment, which is the 0? If you are trying to show a new methodology for something, you must compare it to the old methodology that is used in order to show that yours is better than the old methodology. Because if you don't do that, you just have a different method. You don't know whether it's improved or it's any better or anything like that. So therefore, what are you comparing it to? What's your control treatment? What's your 0? Because without this, you can't do proper variable testing. Types of data to be collected. Quantitative data. Did you get all the numbers? It must fit a normal distribution. Are you testing for normality? Most people just go, we're going to run a test on this. Boom, we didn't test for normality. You must first test for normality. If it doesn't fit, then you might be able to do some sort of transformation. Just don't do a transformation and go, oh, they did it in the past. No, you do a transformation to test for normality. You test for goodness of fit, because what you're looking at is you're looking at differences between one distribution and the next, which means you have to understand normal distribution test in here. This is what your normal distribution looks like. And this is your little graph, and it says you've got all these little spots in here where you're looking at standard deviation, and it should fill out like that. Will the grades in this class fit a normal distribution? Answer to that is hell no. Because if you don't get a B or better, then you fail. It's a graduate level class, which means that we don't have a normal distribution spot in there. I've taken classes where they go out there and they will tell you, if we were going to do a normal distribution in the class, those would be your A's, 13.6% would be your B's, in the middle part would be your C's, your D's would be down on the 13.6%, F's would be over there, which means you would automatically have somebody in the class fail if we followed a normal distribution. Qualitative. Is it discrete data? Discrete data means that you assign different characteristics. When we looked at the calcium level, it says there was a disease rating. You had a possibility of getting a 0, a 1, a 2, a 3, or 4, or 5. They were very discrete sort of things, and you can't run regular type statistics on discrete data. And just taking the discrete data and transforming it doesn't necessarily mean that you're going to get a normal curve fit to it. When you run discrete data, you must use specific type tests for that. Is it binary data? Binary data says yes, no, right? Depends on the question. One of the questions they ask is, I'll let you think about this one. If you have 3 birds sitting on a fence and you shoot one, how many birds are left? This is binary type data. Is it a yes-no question? Is the question even a valid yes-no question? So, these are qualitative data. How do you do things comparatively? Do you do statistical analysis? Did you apply the proper analysis to it? That's why you take a statistics course. That's why you go out and you find people who are knowledgeable in statistics in order to be able to do this. What is your comparison, right? Are you comparing independent versus independent variable? And sometimes we do this. If we do that, we're looking at what we call correlation. Are you comparing independent versus dependent variable? We may be looking at regression. If you're looking at a concentration of something versus a concentration of something else, you may be looking at a regression type equation. And when you do regression, there's a lot of different ways that you can analyze regression. It's not just do you have a good fit on it, but do you have a good fit and are the slopes similar, which means you get a different sort of format out of them. Are you looking at a dependent variable versus a dependent variable, in which case you're looking at a means test? Or are you looking at a dependent versus a controlled variable, in which case you may be looking at a means test, but you're looking at a different type of means test because the dependent versus dependent is an independent type means test, where the dependent versus a control is a dependent type means test. You're comparing the means you got in one area versus the means you got in another area. You can't compare the means from the two different areas together. So you're looking at different ways of doing this, and you need to be thoughtful of this. And you need to think about this before you ever put your experiment together. So when we look at testing, we have to know what we're doing, because there's a lot of forethought that goes into this before you ever really get up and look at it. And then once you do this, you may come up with something like the Phytophthora, where you have to go back and you have to add some more information into it. So all of this comes down to, how do you test hypotheses? And these are basically the concepts we start looking at.